Beneath your feet, a hidden ocean of molten rock constantly churns, silently dictating the very shape of continents. This titanic, invisible engine drives every mountain range, every earthquake, and every volcanic eruption we witness. For centuries, we viewed planetary surfaces as static canvases, slowly eroded by wind and water over vast timescales. Yet, expert geologists now confirm a far more dramatic reality. Planets are dynamic, living entities, constantly remaking themselves. Their ancient landscapes whisper tales of cataclysmic forces, shaped not only by external impacts, but by intense internal pressures. You see, every rock, every canyon, and every vast plain contains a profound geological secret, waiting patiently to be deciphered. These hidden truths reveal a planet's pulse, a deep, rhythmic breathing influencing everything from climate to the emergence of life. Consider Earth's vibrant crust, fractured into immense tectonic plates, riding atop a slowly flowing, superheated mantle layer. This continuous motion, measured in mere centimeters per year, gradually builds colossal mountain ranges and carves deep ocean trenches. It is a slow-motion ballet of immense power, shaping the very land you inhabit without any immediate, visible warning signs. Understanding this internal dance provides the critical key to unlocking the deepest mysteries of our world and others. This fundamental geological engine also determines the distribution of vital resources and influences global weather patterns. Every planet, from arid Mars to distant icy moons, possesses its own unique and powerful geological narrative, constantly unfolding. How does such immense, unseen power translate into the dramatic landscapes we observe across the cosmos? It begins deep within a planet's core, where extreme heat generates vast convection currents within the molten mantle layer. Imagine a colossal lava lamp, its viscous contents slowly rising and sinking, carrying the rigid outer crust along for the ride. These colossal currents act like conveyor belts, dragging and pushing the continental plates with astonishing, relentless force. Where plates collide, immense pressure crumples crustal rock skyward, creating towering mountain ranges like the majestic Himalayas. But that's not the strangest part. Sometimes, one plate plunges beneath another, a process known as subduction, melting back into the mantle. This melted rock then rises again as magma, fueling explosive volcanoes that dramatically reshape landforms and alter atmospheric composition. Consider the Pacific Ring of Fire, a horseshoe-shaped zone of intense seismic and volcanic activity, a direct result of these interactions. Deep beneath the ocean, mid-ocean ridges erupt, continuously creating new seafloor crust, pushing older sections apart across the globe. This constant renewal means Earth's surface is surprisingly young, constantly recycling its ancient geological materials over eons. Yet, the true marvel lies in how these diverse internal engines universally impact planetary habitability. Take mantle plumes, for instance, immense columns of superheated rock slowly rising from the deep core mantle boundary layer. These thermal anomalies can punch through tectonic plates, creating isolated volcanic hotspots far from plate boundaries, like the Hawaiian Islands. Their steady, persistent eruptions build colossal shield volcanoes from the ocean floor, forming entire island chains over millions of years. Scientists discovered these plumes act as unique planetary pressure valves, releasing internal heat and shaping surface topography dramatically. And then something unexpected happened on other worlds, showcasing geology far stranger than anything on Earth. On Jupiter's moon Io, sulfur volcanoes erupt constantly, painting its surface with vivid, changing colors, driven by immense tidal forces. These forces, from Jupiter's powerful gravity, flex Io's interior, generating enough heat to keep its subsurface molten and highly active. Similarly, Saturn's moon Enceladus exhibits spectacular cryovolcanism, spewing water vapor and ice particles high into space from its south pole. This icy geology is fueled by a subsurface ocean, kept liquid by similar tidal heating, hinting at potential conditions for extraterrestrial life. But that's not the end of the story. These deep planetary processes hold even more profound implications for us. These examples demonstrate that internal planetary dynamics are not unique to Earth, but are a fundamental cosmic shaping mechanism. Planetary bodies possess complex breathing cycles, exchanging material and energy between their deep interiors and their outer surfaces. This constant geological recycling influences atmospheric compositions, ocean chemistry, and the long-term stability of surface environments. Ultimately, the hidden machinery deep within a planet orchestrates the grand geological symphony playing out on its visible surface. Understanding these unseen forces is paramount for deciphering a planet's entire evolutionary story and its potential for habitability. The interplay between internal heat and surface manifestation is a universal truth, etched into every crater, mountain, and ocean floor. Unveiling these hidden planetary truths completely transforms our understanding of how worlds form, evolve, and potentially sustain life. It reveals that planets are not mere inert rocks, but rather intricate, self-regulating systems driven by profound internal energy sources. Expert analysis suggests this geological dynamism is crucial for maintaining conditions favorable to life, especially for long periods. Earth's active geology, for example, recycles carbon dioxide, stabilizing atmospheric temperatures and preventing runaway greenhouse or icehouse effects. Without this internal heat engine, our planet might resemble Mars, a geologically dead world with a thin atmosphere and frozen surface. The search for extraterrestrial life increasingly focuses on worlds exhibiting similar internal heat, suggesting potential subsurface, liquid water oceans. Europa and Enceladus, with their cryovolcanic activity, represent prime targets for discovering life beyond Earth, fueled by these hidden forces. Our growing knowledge of these deep planetary mechanisms informs future space missions, guiding instruments to detect subsurface activity. It allows us to interpret distant exoplanet observations more accurately, inferring their internal structure simply from surface features. This perspective also emphasizes the incredible resilience and transformative power of geological processes over immense cosmic timescales.
We are merely witnesses to an ancient, ongoing drama, where worlds are perpetually born, reshaped, and reborn through internal power.
The landscapes we admire are but transient expressions of forces so vast they dwarf any human construction or endeavor imaginable. Every sunrise illuminates a surface sculpted by unimaginable pressures and temperatures, a testament to the planet's enduring, fiery heart. Truly, understanding the hidden geology beneath our feet reshapes our entire cosmic worldview, making the familiar profoundly alien. These revelations continue to challenge long-held assumptions about planetary stability, urging us to look deeper for fundamental answers. Ultimately, every planet is a living geological canvas, constantly painted and repainted by the powerful, unseen forces from within its core. These dynamic internal processes are the true architects of planetary diversity, creating worlds both beautiful and incredibly mysterious. The hidden truths of geology remind us that even the most solid ground beneath us holds profound, ongoing cosmic secrets. If you found this journey into planetary interiors fascinating, subscribe for more incredible stories about the universe around us. Also, let me know in the comments which planetary geological mystery you find most intriguing. Your insights fuel our explorations.